Hello and welcome. The question is, as length of unit cell of a metal having molecular weight is 5 angstrom, which crystallizes in cubic lattice if the density is 2 gram per centimeter cube, then find the radius of metal. Answer is in picometer. Okay. So density is Z into molecular mass upon AQ by NA. So density is given as 2 gram per centimeter cube. Okay. And for the cubic lattice, Z is equals to 1, because we have 8 corners and at each corner we have one atom, and the contribution of each atom at corner is 1 by 8. So Z is 1 and M is what? 75 gram per mole, and this AQ so this is your AQ, and Na is 6 into 10 raised to the power 23 mole inverse. Okay. So if this is your simple cubic lattice, then R is 2R. If this is the radius of circle of the sphere, then 2R is equals to 5 angstrom. So radius is what? So radius is 2.5 into 10 raised to the power minus 10. So we have to find the radius of the atom only. Okay. So radius is, so no need to go into this formula. We will go with this only. So radius is 2.5 into 10 raised to the power minus 10. If we multiply it by 100 and divide by 100, then R is equals to 250 into 10 raised to the power minus 12. So R is equals to 250 picometer. So this is your 250 is your answer. Thank you.
The question is, an element crystallizes in an FCC lattice having edge length of 400 picometers, right? This will be picometers. What you have to do, you have to calculate the maximum diameter of an atom which can be placed in an interstitial site without distorting the structure, right? So if you talk about this question actually, then suppose this is your unit cell. Okay, so let us draw the unit cell for better understanding. Okay, so this is your unit cell. Okay, now what do you have? You have that the element is crystallizing in an FCC lattice, right? So as the atom is crystallizing in the FCC lattice, it means that there are atoms present on the faces, right? So there are atoms present on the faces. Okay, and so this will be your atom on the face, then this will be your atom on the face, then this will be another atom on your face, right? Then this will be another atom on the face. Okay, then what we will be having, then there will be another face, okay, which is going to have an atom something like this, right? Just to understand, I'm drawing it like here because we cannot draw a 3D structure here. So these dots basically represent the atoms present on the 6 faces, okay? And also in the FCC lattice, the atoms are also present in the corners, right? The atoms will also be present at the corners. Okay. So basically, what do we have here? Let us consider that the radius of the atom at interstitial sites. Right. Let the radius of the atom at interstitial sites be R1. Right. And the radius of the atom present in FCC lattice be R2. Right. So if we take the ratio of R1 by R2, we know that the ratio of radius R1 by R2 is equal to 0.225 for a tetrahedral void. Right. And the ratio of R1 by R2 is equal to 0.414 for the octahedral voids. Right. So from here what we can understand? From here we can understand that 2R1 is equal to 2 into 0.414 R2. Right. This is what we can write because we have to find out the diameter. Okay. What we have to find out? The diameter of an atom which can be placed in the interstitial site. Okay. So this is what we have to calculate. So 2R1 is what we are looking for, right? This is the relationship that we are getting from here, right? This is the relationship that we get. So we have written 2R1 in order to find out the diameter. Okay, so for that you need the value of R2 in terms of A. Okay, so how can you calculate that? Now suppose this is the atom at the corner, right? Then this is one atom, then this is another atom, right? So the diameter, now this is your diameter D, right? Let us consider the diameter as D square. Then this will be your edge length and this will be your edge length. So this will be A square plus A square according to the Pythagoras theorem. Right, now what will be D? This will be R2 plus 2R2 plus R2. So that is going to become 4R2, right? This will become 4R2 is equal to, 4R2 square is equal to 2A square, right? So from here we will get A is equal to, what we will get? A is equal to 4R2 by under root 2, right? Or we can say that R2 is equal to under root 2A by 4. This is the relationship, okay? Now if you put this value here, you will get, what will you get? 2R1 is equal to 2 into 0.414. R2 can be written as under root 2 by 4. And what is the value of A? 400 picometers, right? So from here, what we will get? 2R1, which is the diameter, right? 2R1, which is the diameter, it will be equal to 117.1 picometers, right? This is the correct answer. Now remember that this D is the diameter, but this D is the diagonal. Okay, this D is the diagonal that we took from here in this question. Okay, so the correct answer is 117.1. That's all for the question.
Hello everyone, let's start the question. The question says that you are given marbles of diameter 10 millimeter. They are to be placed such that their centers are laying in a square bound by 4 lines, each of length 40 meter, right? What will be the arrangement of marbles in a plane so that maximum number of marbles can be placed inside the area? Sketch the diagram and derive the expression for the number of molecules per unit area, right? So what do we need to do is we need to find out the maximum number of marbles per unit area, and then we have to also sketch the diagram, right? Firstly, what is given to us here, that the marbles are arranged. So let these marbles be like this only, right? So I'm going to draw the structure here, and these marbles are arranged just like the atoms are arranged in a crystal lattice, right? So these marbles are arranged in such a manner that what is said that a square is bound, right? Their center are laying in a square bound by 4 lines, each of length 40 meter. What do we mean by here? That a square is being formed here, inside which these marbles are lying, right? So this is the square which is being formed by these marbles, right? Now what do we need to do here? We need to find out what? We need to find out the area here. So how we'll find out the area? To do so, let me draw this. We need to consider this triangular area here, right? Now consider this triangular area for finding out the number of molecules per unit cell. So let me draw, and each length here is of how much? 40 millimeter, right? Each square length is of 40 millimeter. Now you can see here that these atoms or these marble center, when I join them, I get a triangle. Now I'm going to expand this triangle here only, right? So what do we get here when I expand it? So you can see here, upon expanding, that the length here, let me mark this as A, B and this as C, and let this be D, right? So we have 10 millimeter is the length of each side of this triangle. And what is the angle being formed here? Angle being formed here will be 60 degree, right? 60 degree angle is being formed here. Now we have to find out the length of CD here, right? So how will you find out the length of CD? So CD will be equal to, it will be equal to A sine theta, right? It will be equal to A sine theta. What is the edge length here? It is 10 sine theta. What is the degree angle here? Theta is 60 degree. What is sine 60? Sine 60 is root 3 by 2, right? So when you calculate this, how much you will get? You will get 5 root 3, right? You will get 5 root 3 here, millimeter. So this is the length of CD. Now we have to find out the area of this square, right? We have to find out what the area of the square which have these spherical marbles. So how will you find out the area? To find out the area of the square, let me write down area of a square. It will be equal to 40, right? 40 is the length of each side, into 10 raised to the power minus 1 into 40 into 10 raised to the power minus 1. Now why I am multiplying this with 10 raised to the power minus 1 two times? We know what is the area of a square. The area of a square is given by side square, right? So side is 40 millimeters. Now I'm changing it directly into centimeter, right? I want the answer in centimeter. That is why I've multiplied. What I've done here, I've multiplied here millimeter square, because I was getting millimeter square. I would have been getting it millimeter square. Now I'm changing by multiplying with 10 raised to the power minus 1 two times. I'll be changing this millimeter square into centimeter square, right? So that is why I multiplied this two times. So 40 into 40 will be 1600, right? Into 10 raised to the power minus 2. So you will be getting how much? 16 centimeter square, right? So this is your area of the square. Now the maximum number of spheres which are of how much diameter? It is given the marbles are of diameter 10 millimeter. Area of square is 16 centimeter, and we have to arrange them in an HCP packing, right? So what is the total length covered by these marbles? So the total length covered by this marble, we are finding out the total length. Only then we will find out whether they will get into the square or not. So the total length covered, let me write down, covered by sphere is how much? Total length covered by sphere, right? It will be equal to how much? 5 plus 4 into CD, right? So this will be the value. So again 5 plus 4 plus what is the value of CD? 5 root 3. So you write down 5 root 3 directly here. So the value will come out to be 9 plus 5 root 3. So this is actually multiplication, right? This sign is multiplication. So 5 plus 4 into 5 root 3. So this will be 9 into 5, which is 45 root 3, this value will come out to be this much millimeters. Now to find out maximum number of spheres, so maximum number of spheres will be equal to what? So the maximum number of spheres will be equal to, total will be 14 plus 8. Total there are how many full spheres? There are some full and also there are some half spheres also. I hadn't drawn here earlier, but let me just draw it to mention that some of the spheres must also be coming out of the square only, right? So we have 14 full spheres and we have 8 half sphere, right? So when you add this value, you will get it equal to 18, right? So per centimeter cube, we have to find out the value. So number of spheres per centimeter square will be equal to 18 divided by 16, right? So the value will be equal to 1.125. So the value will be how much? 1.125. The correct answer to your question, that is the number of sphere per centimeter square lying inside the square. So this is your answer to the question. Thank you.